Today we will discuss about the permutation and combination, not elaborately permutation and combination, but just using the algebra of permutation and combination. Because next class we will do the binomial expansion. So for doing binomial expansion we have to some knowledge about permutation and combination, basically not only the conceptually but notationally or algebraically. So what about NPR, what is the value of 3p2 or 6c3, C for combination, P for permutation. So that's why I have introduced some notationally or algebraically the permutation and combination. So first we have to know what is the factorial. So factorial, if n be any positive number, if n be I have to introduce the factorial notation. What about factorial? If n be any positive number, I have to say correctly, politically correct, n be any non-negative number and factorial n is denoted by angle of n or n exclamatory sign. The factorial n is denoted by this, either this or n exclamatory symbol, and is defined as n factorial. I am familiar with this notation. So this equals to n into n minus 1 into n minus 2 into n minus 3 up to 3 into 2 into 1. Okay. So product of the n numbers and decreasing 1. Okay, n, so decrease by 1 n minus 1. The next step decrease n minus 1 by n minus 2 and n minus 3 up to 3, 2 into 1. The product of these numbers. This is linked with the multiplication principle. So we have already done about the multiplication principle in the number theory lecture or number theory video. Okay, you can see the you go to the playlist and you can see the number theory, and on that part I have already discussed about the multiplication principle and the factorial notation. So what is factorial n? Factorial n is n into n minus 1 into n minus 2 into n minus 3 into 3 into 2 into 1. For the special case, if I calculate, what about the 3 factorial? So 3 factorial, 3 into 2 into 1. Okay, you start from that number and decrease 1, 1, 1, and product of these numbers you will get factorial. So what about the 4 factorial? So that is 4 into 3 into 2 into 1. So that gives 24. This gives 6. What about the 5 factorial? 5 into 4 into 3 into 2 into 1. Interestingly, you see that if you write down here the 5 factorial, what about this part? This is the 4 factorial. So you can write down 5 into 4 factorial and put down the value of 4 factorial. You will get the result easily. So this is 120. So in this fashion we can calculate the factorial. Okay, we can calculate the factorial. Okay, next another part is that you have to remind it and keep it in your mind. The factorial 1 is always 1, and because the 1 quantity, and 0 factorial, the factorial 0 there is a big confusion. The value is always 1. Okay, so this is the most important, 0 factorial. And someone asked you the question, what is the proof? No, this is conventionally true. This is 0 factorial is 1. It cannot be proved. That is the statement. 0 factorial is always 1, value of the 0 factorial. And you see that I have already done. So what about the 7 factorial? So 7 factorial equals to 7 into 6 into 5 into 4 into 3 into 2 into 1. So you can write down also 7 into 6 factorial. Okay, so because this part is the 6 factorial, and anyone can be written as 7 into 6 into 5 factorial. Okay, 5 factorial, because 5 into 4 into 3 into 2 into 1, that is also 5 factorial. Okay, 7 into 6 into 5 factorial. So why we have done in this fashion? Because of, so someone asked me the question, what is the value of 11 factorial by 7 factorial? How to calculate 11 factorial by 7 factorial? How to calculate? You have to put down all the values of, that means you have to write down 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 by 7 into 6 into 5 into 4 into 3 into 2 into 1. We are calculating in this fashion? No. Why are you doing this? You can calculate 11 into 10 into 9 into 8 into 7 factorial by 7 factorial. So 7 factorial cancel, and if 110 into 72, after the calculation you will get the required result. So due to this, so for simplification or for calculating, for the simplification, we can do in this fashion. Okay, another question. You have to calculate that what is the value of 13 factorial by 10 factorial. So just I reduce this 13 into 12 into 11 into 10 factorial, because 10 factorial already present in the denominator part and you can cancel it. Okay, so 13 into 12 into 11, after multiplying these three expressions you will get the required result. So in this way we use the factorial notation. Factorial notation is nothing but the number of multiplication, consecutive numbers multiplication, just you have to write down as a simplest form, smallest form, okay, and handy form. Okay, next, that is the factorial notation. So I have repeatedly mentioned it here. So what is factorial n? Factorial n means you can write down n into n minus 1 into n minus 2 into n minus 3 into n minus 4, 3 into 2 into 1. Okay, so if you want, you can write down n into n minus 1 factorial also. If it is needed to you, then you can write down n1 into n minus 2 factorial. Okay, so this n minus 2 factorial means n minus 2 into n minus 3 into n minus 4 up to 3 to 1. Okay, so now next we introduce what is NPR, not conceptual, just I have to introduce only notationally what is NPR, what is NCR. Now NPR, that means permutation, NPR, of course R less than equals to N, R less than equals to N. So by the definition, NPR, that is the permutation, taking R objects from N objects and arrange it. Okay, if you take r objects at a time from n objects and arrange it, you will get that is npr. So we are not bothering about what is the npr, just we are bothered only the symbol of npr, because we have already known that what is factorial. So factorial n by n minus r factorial. npr means factorial n by n minus r factorial. So what about the 4p2? What is the value? Here n equals to 4, r equals to 2, that is 4 factorial by 4 minus 2 factorial. So we will get 4 factorial by 2 factorial. So someone wrongly answered that is the 2 factorial, cancel 2 2. No, you have to write down 4 into 3 into 2 factorial by 2 factorial, and 2 factorial cancelled will give the result 12. Okay. Next part, what is npr? Now what is np0? What is the value np0? That means np0 means factorial n by n minus 0 factorial. So that gives n factorial by n factorial. So that is 1. This is the important result. What about np0? np0 is also 1. What is npn? What is the value of npn? So npn equals to factorial n by n minus n factorial. So factorial n by 0 factorial, and 0 factorial is always 1. So factorial n by 1, that is factorial n. So the value of npn equals to factorial n. Next, these are the calculations. You can calculate easily what is npn minus 1. So you can write down that is factorial n by n minus of n minus 1 factorial. So factorial n by n cancelled, so 1 factorial. So that gives factorial n. So npn minus 1 equals to factorial n. I think what about npr? If anyone someone give, so 13p2, what is the value? 13p2. So that is 13 factorial by 13 minus 2 factorial. You will get 13 factorial by 11 factorial. So that is 13 into 12 into 11 factorial by 11 factorial. So these are cancelled. So the answer is 13 into 12 and 36, 156. Okay. So you can easily calculate npr or anything, any number is whatever the values of n and r. Next part we will discuss about what about ncr. I erase this part. Okay. NCR, that sometimes called combination. In Bengali it can be said as a samobai combination, and in Bengali permutation is known as binyash. So combination, that is NCR. So NCR, sometimes it can be denoted as NCR, first bracket n by r, sometimes column vector nr or ncr. So that's equals to factorial n by r factorial into n minus r factorial. After simplifying this, we will get the ncr. Okay, so what about the 5c2? So factorial 5 by r equals to 2 factorial into 5 minus 2 factorial. So we will get 5 factorial by 2 factorial into 3 factorial equals to, okay, after this, what about the 5c3? 5c3, 5 factorial and 3 factorial into 5 minus 3 factorial. So we will get 5 factorial by 3 factorial into 2 factorial, and you can write down also 5 factorial by 2 factorial into 3 factorial. The number you can a dot b equals to b dot. A into b equals to b into a. Any real number. Okay. This is not a vector. So these two expressions both are same. So what is the value? The value is that factorial 5 you can write down 5 into 4 into 3 factorial, and 2 factorial 2 into 1, and 3 factorial as it is. So 3 factorial cancel. So that gives 10. This also gives 10. So interesting part is that the value of 5c2 and the value of 5c3 both are same. Okay. So two numbers are same. Logically the expression is same. Okay. So in this case we can explain that the NCR and NCN minus R both are equal. NCR and NCN minus R both are equal. How? So this example certifies that what, so you can calculate easily, okay, NCR and NCN minus R. So what about NCR? NCR this. And what about NCN minus R? According to the combination formula, n factorial by r factorial, here r equals to n minus r into n minus r factorial. Okay, so you get n factorial by n minus r factorial, and this n cancel, minus plus r, so this is r factorial. And in this NCR or NP are always true for non-negative integers. Okay, so fraction cannot be defined and negative cannot be defined. Negative of permutation, negative of combination, negative of factorial cannot be defined. Okay, so only this n, r, all are things are non-negative integer. So you see that NCN minus r equals to factorial n by r factorial n minus r factorial product, and both are same. You see that. So that's why 5c2, and you can write down 5c 5 minus 2, that is 5c2 and 5c3 both are same. Okay, using this result, and I have already proved it in calculative way. So NCR and NCN minus R both are same. Okay, NCR and NCN minus R both are same. So next I erase this part. What about NC0 and NCN? So we have already done NCR equals to NCN minus R, and this equals to factorial n by r factorial into n minus r factorial. So what about NC0? So NC0 is by definition factorial n by 0 factorial into n minus 0 factorial. So you will get n factorial, 0 factorial equals to 1, and n minus 0 factorial, that is also n factorial, and n factorial cancel, that gives 1. So what about NCN? So you can write down NCN as a, using this result, NCN minus 0, NCN minus 0, that is NCN, that gives also 1. So n factorial by r equals to n factorial, n minus n factorial. So you will get factorial n by n factorial into 0 factorial. So this gives factorial n by factorial n into 1, and both are cancelled, you will get 1. Okay, so NC0 and NCN, both the values are 1. NC0 and NCn, both the values are same and both the value is 1. You remind this result. And now I have not derived here, so I will not derive here, just I write down some expression, some result, remind it and calculate in your home, you will get the same result. NCR, I erase this part, NCR plus, this is the most interesting result and you can use each and every time this result, NCR plus NCR minus 1, that gives N plus 1 CR, N plus 1 CR. If you calculate, you will get the result. Okay, so using this result, what is the value of 5C3 plus 5C2? So if you separately calculate it, 5C3 plus 5C2, you will get 6C3. You calculate it separately and justify. So what is 5C3? 5C3 and 5C2 both are 10. We have already calculated 10 plus 10. And what about 6C3? 6C3 6 factorial by 3 factorial, that's equals 3 factorial into 6 minus 3, that is 3 factorial, and 6 into 5 into 4 into 3 factorial by 3 into 2 into 1 into 3 factorial, both are cancelled, 3 to 6, 20. So this is 20. Clear? So 5C3 plus 5C2 equals to 6C3. Using this result, this is the most interesting result, and we will use this result in different type of problems also. So what are the conclusions? The conclusions is that we have gotten the result, this one result, and NC0 equals to 1 and NCn equals to 1. Okay, keep it in your mind, these results, NCR and NPR, and then we will solve the binomial expansion. For this lecture also helpful for doing the binomial expansion. Okay, thank you.